All right, all right, all right, all right. You're back. We're back. All right. So, in the last lesson, we talked about what happens when we put a number in front, right? And that basically stretched it. If the number got larger, the max and min moved to whatever that number was. If it got smaller, the max and min moved to whatever that number was. So it's some kind of stretch or shrink. Now today we are going to add onto the entire equation. We have done this before with other types of graphs when we were doing transformations in Unit 7. Just because it's a sine and a cosine curve does not mean that something different happens. It is the same exact transformation. So can you remember what it is? The title may have given it away, but yes, it's a vertical shift. In exercise 1, it says consider the function f of x equals sine of x plus 3. What do you think is going to happen to the graph? So part A says the graph of y equals sine of x is shown. So that is what we graphed last week. It's the basic sine curve. How would it be shifted to produce the graph of f of x, meaning the equation given up top, sine of x plus 3? And then part B says on the grid to the right, they want you to graph the sine of x plus 3. You can put this in your calculator if you want. It should do exactly what you need it to do, but I want you to see what's about to happen. I'm going to move this up 1, 2, 3 units. So you can see it is exactly the same in shape. The height and the amplitude are the same, right? The max and mins are all in the same, pi over 2, 3 pi over 2, they're in the same spot, just everything has moved up 2 units. Now, you can put this in your calculator, but it doesn't always give you, in the table, it doesn't give you whole numbers, it gives you decimal forms, and it becomes kind of messy. So if you know what the sine curve looks like, and you know that you're doing sine plus 3, you just have to move everything up 3 units. Exercise 2 wants us to consider this function right here, 2 cosine of x plus 1. They want us to give the equation of a horizontal line that this curve rises and falls 2 units above, sketch the line of this graph. Use your calculator, sketch the graph on the grid to the right, state the range. Okay. I am sort of going to do A and B together. A sort of doesn't make any sense until you try to graph it. So I'm going to do them at the same time so you understand what they're talking about, the horizontal line that is in the middle. Before I even do that, though, I am going to sketch the graph of a cosine curve just as a quick little reference. Voila, like magic. By the way, if you are somebody who is also doing these on your iPad, it's not easy drawing the curve with your finger or stylus, especially since mine is kind of like broken, but I found that the thicker the line you make, the better it looks. It's a little bit more forgiving. So what I'm going to do right now is I'm actually going to put both of these equations in the y equals in my calculator. So the cosine of x and 2 the cosine of x plus 1. I want to take a look at what they look like. So my blue curve here is my cosine, and then the red one is the 2 cosine plus 1. So the shape is not the same. It has changed and it has moved. So what I do know is that because I have the 2 in front, my height is 4. It has to be 4, right? If I look at my min here, it is -1, okay? And then if I look at my max there, it's 3. Well, the difference between 3 and -1 is 4. But the problem is it's also shifting up 1 unit, which makes it a little bit more tricky, okay? So what I want to point out is that when you do the regular cosine curve, the x-axis sort of acts as a middle ground, right? It cuts the graph in half. We didn't really talk about that as much because it just happened naturally, and it was doing that for every single one. But that is now not the case for my second graph, my red graph there. That x-axis is not cutting it in half anymore. And in order to graph it properly, we need that middle line. We call it the midline. It's also like a line of symmetry. So in my red graph, that line is not cutting it. We need a different line. So that's what part A in the question is asking us to do. So if I were to look for what cuts this in half, I would say about right there is cutting my red graph in half. Right now we're ignoring the blue graph. All right, so where is that? I'm crossing at 1, y equals 1. So what I'm going to do is I'm going to get rid of my blue graph, and I'm going to go into my y equals, and I'm going to put in y equals 1. All right, so what I'm talking about is in my y equals, I've gotten rid of that cosine, and I'm just putting in y equals 1. It should be a straight line. I'm changing the color to black just so it's not confusing. And in my y2, I've not changed anything. I've left that the same. So when I hit graph, it's graphing y equals 1, and now it's graphing my cosine curve. Now, doesn't that look like it is a line of symmetry? It now acts as if that is the midline right there, not the x-axis. Interestingly enough, that y equals 1 matches something in our equation, and that is not a coincidence. So what I'm saying is notice right here that plus 1, it does mean move up 1. The whole entire graph is moving up 1. But it also means that my midline is moving up 1, or it's equal to whatever this is. So my midline, I'm gonna sketch it in here. I'm not gonna make it perfect. Is now right here. So now that I know that that is my midline, I should be able to sketch everything else, meaning that my starting is 2 above here, right? And then I come back to cross this, and then my min is 2 below here. Come back up to my midline, and now it's 2 above. Same thing going backwards. I'm starting up there, I'm coming back there to the midline, I'm coming down 2, back up 2, then up 2. And now I'm going to connect as smoothly as I can. It's okay. So that does look closer to what was in your graphing calculator. So this plus 1 is the midline. It's another vocab word, sort of. It doesn't have an official name, official definition, but know that it is cutting the graph in half. If you graph that first, you're in good shape. And a little reminder, I went up 2 because of that. I came back to my midline and went down 2 because of that. And that was from the previous lesson. Now the last part wants us to state the range. Okay, what is my lowest point? My lowest points are here. Well, my y value there is a -1. What is my highest point? Well, this is my highest point, this is my highest point, and this. They all have the same y value of 3. So that's my range. Notice that my height is still 4. 2 up, 2 down, but the difference between -1 and 3 is 4, and my amplitude is 2, which matches that 2 that's out front. On the next page, what I just explained is given to you. It is important. For curves that have the general form y equals a sine of x plus c and y equals a cosine of x plus c, the c value is called the midline or the average value. You're going to hear midline more often of the trig function. It is the height or horizontal line that the sinusoidal curve rises and falls above and below a distance of the amplitude. So basically they're saying the midline is the c and the amplitude is how many up and how many down from that line. For exercise 3, they want us to sketch and label those two functions, y equals the 4 sine of x minus 2 and y equals the -2 cosine of x plus 2, plus 3 on the grid below. So these two equations here, I've kind of just zoomed in a bit. All right, so we're going to do those two equations. Then we have to state the range. All right, so I am going to start with the sine curve. Now remember, the sine curve always starts in the middle. So the first thing I'm doing here is I am going to identify my midline. So my midline is y equals -2. It's this guy here. So I'm going to draw that in. I'm going to highlight it just so it's easier to draw. So y equals -2 is here, right? This is -1, -2, down. My amplitude is 4, meaning I'm going to go 4 above and 4 below the midline. And it's a sine curve. So I'm going to plot my points first, and I think I'm going to have to move this over just a tiny bit. All right, so on a sine curve, we always start in the middle. Then we're going to go up 4 at our next little tick mark, the pi over 2. So we're gonna go up to 4. So 1, 2, 3, 4. Come back down to the midline. And now at 3 pi over 2, we're going to go 4 below the midline and come back up to the midline. Now I'm going to connect that part. That's okay looking. And I'm now going to plot my points backwards. So if I'm going backwards, when I go to negative pi over 2, I'm going to go down. If I'm at the center, I'm going to go down 4 below the midline. For negative pi, come back up to the midline. For negative 3 pi over 2, we're going to go up 4 from the midline, which should give you the same max. And then at negative 2 pi, you're coming back to the midline. And you're going to try and connect that with a nice smooth curve. And there we go. Now to answer the question about the range for this graph, I'm going to find my lowest point. So for my range, since I have all my dots are filled in, it's a hard bracket. It's not even a question of whether it's going to be soft in these. And my lowest points are here and here. Well, what are my y values there? Be careful, count from the x-axis, not from your midline. That's going to mix you up a little bit. It's -6. And then what are my highest y values? Well, those are here and here. And again, count from the x-axis. And that is 2 with a hard bracket. Now moving on to the -2 cosine of x plus 3. First thing I'm going to notice right here that is my midline, and then the -2 is my amplitude. So let me just write that down. So my y equals 3 is my midline, and my amplitude is 2, but keep in mind here that it's negative. It's going to be the opposite way. So first and foremost, I am going to draw my midline at y equals 3. 1, 2, 3. So that is here. So this is the line of reflection. Now, in a regular cosine curve, my first point would be 1 above that midline. It would be right here, right? But now that my amplitude is 2, I would go up 2 and it would be here. However, it's negative, so I actually need to go down 2 and put it there. And from here, I'm going to follow the same pattern that I had been in this lesson and the last lesson. So if I'm going from left to right, I'm going to come back up to the midline, mark a point. And then the next one for pi, I'm going to be 2 above. Then for 3 pi over 2, I come back to the midline. And for 2 pi, I'm 2 below the midline. And before I draw that, I'm going to keep going backwards. So if I go back to the origin, if I'm moving backwards to negative pi over 2, I'm back up to the midline. Negative pi is 2 above the midline. Coming back down to negative 3 pi over 2 is back to the midline. And then negative 2 pi is 2 below the midline. And then you're going to try and draw a nice smooth curve there. And I'll come back after my 5th try. And there we go. That was really only my first try. Now, real quick, let's do the range. I just need my lowest and my highest point. It's going to be a hard bracket. So these are my lowest points. What are my y values on all those points? It's 1. And then what are my highest points? Well, this one and this one. What are my y values there? Be careful, you're counting from the x-axis. 5. Notice that the distance between 1 and 5 is 4, right? Your height was 4 because your amplitude was 2. You double that, you get your height. Now, here's a little trick on getting your range without even graphing. If I look at my sine graph, if my midline is -2, and my amplitude is 4, I am going to take my -2 and subtract my amplitude, which is -6. Then I'm going to take my midline of -2 and add my amplitude, and that gives me 2. Same thing. Weird. Let me try this down at the bottom. So if I take my midline of 3 and subtract my amplitude of 2, that gives me a 1. If I take my midline of 3 again and add my amplitude of 2, I get 5. Exactly the same. Of course, you can always refer to your graph, but it's a nice quick way to do that. The next section, question number 4, wants us to do what we just did. Determine the range using interval notation. You can always graph these, and please, I encourage you, if what I'm doing is a little confusing to you, that is fine. Put it in your graph, look for your lowest y value and your highest y value, and you should be getting the same answer. For now, I'm going to highlight, this is my midline. And the 7 is my amplitude. So if I want to find my range, I'm going to make a hard bracket, and I'm going to take my midline of 4, and I'm going to subtract my 7. That gives me a -3. I'm going to take my 4 again, my midline, and I'm going to add 7, and that gives me 11. So my range is from -3 to 11. Please double check it in your calculator and let me know if that's not correct. So on the next one, I'm going to mark them again. 2 is my midline. And -5, or really just the 5, is the amplitude. The negative we don't really worry about as far as the amplitude. That just affects that the graph is a reflection, but it doesn't affect the amplitude. So now I'm going to write my range. So I'm going to take my midline of 2 and subtract my 5, which gives me a -3. Then I'm going to take my midline again, and I'm going to add my 5, which gives me a 7. Same thing for the last question. 35 is my midline, and 25 is my amplitude. The only downside to graphing that one is you really are going to have to change your window a lot. It's going to be completely stretched out, but it's completely doable. But in this case, it's actually a little quicker to do it this way. So to find my range, I'm going to take my midline of 35 and subtract 25, my amplitude, and that gives me 10. So your minimum is 10, so you're going to be moving your Y max up a lot in your calculator. Then I'm going to take my midline 35 again and add 25 to that, and that gives me 60. Exercise 5 says the graph below shows a sinusoidal curve of the form y equals a sine of x plus c. Determine the values of a and c. Show how you arrived at your results. Interesting. All right, it is cut off, but I do feel that you should know that this does say pi over 2 is your x value here, and -pi over 2 is your x value there. It doesn't actually affect anything that we're doing, but it is sort of annoying that it is cut off. Really pay attention here, because this is how you're going to have to do a lot of these problems moving forward, where you have the graph and you have to write the equation. The nice thing is they tell you it's a sine curve. You kind of know that by looking at it, because the middle looks like it's right there on the axis, okay? But we have to figure out A and C by ourselves. So if you remember, C is the midline, which is here. I'm just going to do that quickly. But I don't know what it is, because the x-axis, the y-axis is not labeled. I don't know what that is. So for now, I'm going to erase that, especially because it's crooked. I'm going to come back to the midline in a second. A is the amplitude. It is the distance from the midline up and the midline down. But I don't have the midline. But I do have my range, right? My range will also give me the height. So my range, my lowest point is 6. My y value there is 6. Do we agree with that? All right. And my highest point, my y value is 22. So that's my range. Well, in order for me to find my height, right, I could count boxes, but I don't have boxes. So I'm going to do 22 minus 6, which would give me 16. So that's my height. So what I'm saying is that from my max to my min, my height is 16. So that whole thing is 16. So how could I find what my amplitude is? Let me draw back in my midline here. So don't you agree that my amplitude would be half that? Before I was saying the height is twice the amplitude. Well, if I'm working the other way, to find my amplitude, I'm going to take my 16 and divide it in half. and that's going to give me an 8. Now, if I now know that this distance is 8 and this distance is 8, I can find that midline. I'm going to take my max of 22 and I'm going to subtract my amplitude. And that is going to give me 14. So I believe my midline is 14. However, let me double check myself. I'm going to take my min of 6 and I'm going to add my amplitude of 8 and I also get 14. So my midline is y equals 14. What I really needed here was my midline and my amplitude. I'm going to plug that into the equation, but I'm also going to explain it a little bit further on why I know that works. So my equation is y equals my amplitude of 8 sine of x plus my midline of 14. All right, so I'm just zooming in on this graph a little bit, and I just want to explain to you what I figured out. So if I look at my equation, my midline is 14. So that means right here, that's 14. Okay? So this is my midline. My amplitude is 8. So if I want to get from here, and I'm plotting my next point, and I'm going to go up here, I'm going to take my 14 and I'm going to add 8 to it. And what does that give me? That's right, it gives me 22. Now, I don't know the coordinates at this point here. So, I mean, I know what they are, but it's not given. So, but if I were to go, my next point, I would plot here right on my midline, right? Then the next point, I would go below the midline. So I would take my 14 and I would subtract away my amplitude of 8, and that would give me 6. And that's why it works over here. If I'm going backwards and I subtract 8 from my 14, it gives me 6, and that's why that works. So I'm going to end the lesson here. It's a lot to take in. I strongly suggest that you join me on Friday afternoon at 12:30. There are 2 homework questions that are like this one that I just did. And also, I don't know why a PDF is cutting off the numbers. So if you're working from a PDF, which makes a lot more sense because it doesn't mess up the formatting, on some of the graphs, you can't see the coordinates. So just look back on the Word document that I sent you, so it's a little bit more clear. Anyway, I hope to see you all on Friday. All right, bye.